It takes many engineers' efforts and time to make a product with minimal defects through casting. This is the result that takes long time of collaboration between a designer with mold knowledge and an engineer with casting knowledge. Then, what should be done to produce a good product? From a broad perspective, technical reviews must be conducted for all tasks, such as gating design and casting analysis, in the overall design stage before production. AnyDESIGN HPDC, which I tell you from now on, can be used to minimize the time from design to product production and maximize the collaboration efficiency of each part engineer. AnyDESIGN HPDC is optimized for gating design after product design, and anyone can use it without difficulty in design due to its high usability. As a knowledge-based program, it is possible to verify the design with the casting engineer's concept gating design. Casting analysis can be confirmed in a short time. In addition, clear exchange of opinion is possible and the required time for work is minimized. From a business point of view, the cost aspect can also be considered. Above all, the most important thing is that anyone can use. Looking at the workflow from general product design to gating design, product manufacturing takes place through multiple stages, as shown on the screen. We will explain how to use AnyDESIGN HPDC within the workflow to make gating design part faster and more convenient. To create a new project for design, first, click New Project to set alloy, machine and mold size. In this setup, machine and mold sizes are approximate choices, subject to change at design time. In particular, the size of the Z-axis mold is determined by the height of the sleeve and the thickness of the product. It must be changed during design. Biscuit location is automatically selected according to machine spec. Design target sets the casting yield, filling time, gate speed, and gating and venting ratio values that the designer aims for. When designing, it compares with the design values to help design modifications more convenient. The filling time calculated within the design target are not simply calculated based on the product thickness. It is a detailed formula provided by NATCA and is calculated by considering 4 items other than wall thickness. Product import can be done by clicking the product icon, and the product modeling format supports Parasolid step formats. Movement, rotation, and centering of imported products can be done by numerical input. Simple operation using the mouse is also possible. Screen manipulation is possible in plus or minus, Y, and Z axes using the default viewpoint, and about 45 degrees angle viewpoints are set for all axes for convenience during design. Screen view operation can be operated more easily through the buttons from number 1 to 6 on the keyboard. User viewpoint maximizes design convenience by saving your own view with a viewpoint save function set by the user. The material assignment is carried out using Material Assign. It can be selected casting, mold material from the database. The properties of the assigned material are used in multiple calculations. To check the projection area, user can find out by clicking the clamping and tie bar icon located in the Analysis tab. The casting pressure required when calculating the mold opening force is calculated using the cross-sectional area of the plunger of the currently selected machine, the cross-sectional area of the hydraulic cylinder, and the ACC pressure. Selected a machine with a clamping force considering a safety factor of 20 to 25% based on the calculated die opening force. The center of area function is a function that automatically adjusts the position to have the same 4 quadrants as possible centered the entire projected area. Tie bar force is expressed as the force applied to each tie bar and the ratio value according to the center of the quadrant. When the machine selection is completed, before starting the actual design, it is necessary to proceed after calculating the approximate cross-section of the ingate. AnyDESIGN HPDC uses PQ-square analysis to calculate the ingate cross-section at the most stable operation point position and provides it to the user. A stable ingate cross-sectional area can be found in the recommended section, and the ingate design is started based on the recommend ingate cross-section. By activating the draft angle function to set the parting line, user can easily check the fixed and movable slide core direction. The draft angle function can be set without much difficulty when setting the parting line by expressing each angle in color. The parting line is selected using the mouse, and the automatic recognition function for lines located on the same line enables more comfortable setting. AnyDESIGN HPDC is optimized for the HPDC process gating design, and design elements required in the HPDC process can be designed with the concept of entity. After selecting Ingate from Home or Modeling tab, use the mouse to install Ingate and install it. It can be resized by using the mouse or by adjusting the input value in the description window for the installed entity. After installing the ingate at an appropriate location and then compare and correct the cross-sectional area of the ingate recommended in PQ-square. Runner design is possible by using the multi-work plane feature to align the design with the parting line. The shape of the runner is realized using the runner path, and the connection with each runner path uses the joint and branch functions to automatically process the round and fillet work, which is difficult to work with in general CAD. The greatest advantage of AnyDESIGN HPDC design lies here. Connection and rounding work, which can only be done by workers with high proficiency, can be done in a short time by anyone with a rough design concept. In particular, areas with a lot of work, such as biscuit to runner area, can be created in a short time with simple numerical settings. The approximate flow direction can be checked through the designed runner shape. This is the flow direction located in the Analysis tab. The flow direction briefly expresses the direct direction of the melt injected from each ingate, helping to select the location of the overflow and vent. The overflow design is designed using the overflow and vent path located in the Home or Modeling tab. Overflow and vent design can be created faster and easier than any other CAD program in the same way as runner design. At the completion of the design, the section tracking is used to verify the cross-sectional area. Using section tracking, it is possible to automatically verify the cross-sectional area within the runner without the need to locate individual sections. Next, health check is executed to check the details of the overall design. Design target, product overview, PQ square analysis, shot profile. Gating area and venting area. Evaluation of atomized flow. Atomized flow is the value related to the blowing force of the melt flowing in from the ingate. As shown in the standard table on the screen, if it has a value above a certain J factor when using aluminum alloy. High speed and small drops of melt are possible through the ingate, resulting in high speed. It can make a great contribution to the production of quality products by enabling filling and spraying of melt on the entire inside of the product. If user want to modify the completed design in General CAD, user can export it as a parasolid or step file that is the same as the format used for import, and user can also use the STL format. When immediate connection from AnyDESIGN HPDC to casting analysis is required, execute simulation located in the Analysis tab is used. And when any casting is installed on the same PC, the corresponding function is linked with AnyPro to perform automatic modeling import. With extensive knowledge through various literature research and field review specialized in high-pressure die casting and concept gating design that anyone can use. We show design beyond design.